All right. Hello, everybody, and welcome to the stream. I hope everybody's doing well tonight. We are picking up where we left off last week, plus a few things I was able to get done off camera. Well, more than a few things. So we've actually moved forward quite a bit from where we were last week. And we'll go over all that stuff, as we get into the stream and whatnot. Tammin, good to see you. I am doing well. How about you? Welcome, welcome. All right, before I get into too much of what we're doing tonight, I do just want to take a quick second and thank the supporters of the channel, beginning with our elite partner, Javier Lazaran, and our partners, Gerbolis Inc. and Matt Osgard. Those make up the highest tiers of subscription over on YouTube memberships and Patreon. I would also like to thank the other supporters listed here. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and is going to help me offset some of the costs in running the channel and eventually paying folks that I need to make assets for me that I'm not capable of making myself, right? So all of that funding is going to go towards that. Speaking of that, I just want to also mention that, of course, I appreciate each and every one of you viewers, whether you're here on the stream live with me on the YouTube side or the Twitch side, or if you're just catching the VOD after the fact. I greatly appreciate you guys being here. Without you guys, this project and thus this game would not exist, right, in the channel. So thank you guys very much. Kakali and Grueling Pine, hello, over there on the YouTube side. No, Dr. Elliott, you're not first tonight. Oh, your vacation's over, Tammin. Yeah, I understand that feeling all too well. Back to work. Make it a robust logger. Nice. All right, so I suppose I probably ought to show you guys a little bit of visual in terms of where we are. So I'm going to go ahead and run this and just let you guys get kind of a look at what we have so far. Now, there are some issues here that I'm working through. But I figured it would be prudent to kind of give a little bit of a visual update here. So I do have the new physics system in place. I do also have a camera update where it sort of tweens that animation there when we turn and whatnot. That does have an issue that we're going to see here in just a second. Because we're using Euler angles for that, which is typically what you use for a camera. And we've got some weird issues around flipping some of our rotations to not gimbal lock. And then when that happens, we are having some issues in terms of how we translate or interpolate between those two things. So as I round this corner up here, you're going to see the camera sort of flip out. I know that's an issue. It is something I'm going to address. But we can now go along the track, and we can, there it is. There's that camera issue I was talking about. We can go along here. We can run into the guardrails and everything. And we've even got a little bit of a jump there that you can see. So we can, kind of land down here. And then, we've just got a little bit of extra stuff here in terms of like extra guardrails and stuff like that. So what are we looking at? We are looking at the new physics system in action. Now, there's a lot of work left to do on this. So the way that this is working currently, and you'll notice there's a few issues, like it's continuously sliding, right? Because we're not clamping that down when we've stopped. There are a few issues here, but the way that this is represented in the world is right now the vehicle, which is sort of this box that we're seeing here, in physics is actually represented as a sphere because that's the simplest thing to get working. And then the track itself, of course, is represented by the polygons of the track itself, right? So we can bounce off of those and slide along them as we need to. And that all seems to work fine. The other thing that we can do that we could not do before is we can actually jump off the side of the track, which I'll show you here in just a second. So all of that seems to be working just fine. And it seems to be pretty stable and relatively fast, even though we haven't done a whole lot of optimization for it whatsoever. So it's completely unoptimized. The code's frankly a mess because it's just in the middle of sort of being made. So we're gonna kind of maybe look a little bit at that tonight. And you'll notice that I've also expanded the track to be a lot more segments all the way around. So one of my goals for tonight is to make the track configurable. I'd like to really get that in so that we don't have that hard-coded, so we can just change that without having to change the track code. And then the other thing is all of the logic that we did, sort of figuring out our initial point physics, point-based sliding physics along the track itself. That's all going to be removed, right? We were able to reuse portions of that for our physics system, but basically what we have in place now is we have the sphere to triangle mesh interaction complete. I also did start on oriented bounding boxes, right, which would be ultimately what we'd want to probably represent this shape with, maybe. But that still needs a lot of work. It's not stable yet. So the other thing I should point out is I may actually stick with this collision model just because it kind of feels right as you're going around the track, right? And so we'll take a look at some of the properties that maybe we can start thinking about utilizing for properties of different vehicles and things like that. Like some vehicles have better handling. Some vehicles will be faster than others. Some vehicles will, have better turning capability, things like that. And so the other thing is, this is a fully physics-based world right now. We're not constrained to the track anymore. So if I wanted to, I can jump off the track and fall into nothingness, right? And so we probably ought to put like some sort of ground plane so that you don't just continue falling for forever. But that's basically where we're at the moment. All right, let me catch up on chats here. Looking good. I appreciate that. Yeah, it's coming a long way. Quaternions and slurps for the win. Yes. I thought about converting the camera system to quaternions. I just haven't actually gotten there. And I started actually doing some work in the math library to support that, but we're not there yet. So what I'm thinking is eventually I'd like to... The thing I've got to figure out is how to correctly represent pitching and yawing a camera with quaternions, right? Because it's not actually using those Euler angles under the hood when we do that. That and correctly generating the view matrix off of that, and there's a few things that we've got to figure out. So I'll probably have that figured out by next week if I wind up switching that. But yeah, that's kind of the issue that you're seeing there with the camera. Apotham, good to see you. Welcome. Let's see. Greatly appreciate your work on this game engine in an open source manner to teach us and give us knowledge. Well, I hope it's useful. I appreciate the kind words, though. Thank you. Sakelos Music, good to see you. How have you been? I actually, at some point, I need to DM you, actually, so we can start talking about music stuff. That's a long way off, but I wanted to start talking about it at some point. If you're free at some point. So I don't know if you wanted to shoot me a DM on Discord, and I'll answer it when I can get to it, but just so I have a visual reminder there. Because I know I did want to talk to you about that. All right. So I guess let's take a look at the physics system that we have in place. And you're going to see all kinds of stuff in here, like to-do, hack, all this other kind of stuff, right? And that's because there's a lot of that left to do, right? So I guess I can start with the header file first, right? This hasn't really changed all that much, but there are a few things that I wanted to kind of point out. You know what? I'm going to get rid of this other buffer. So one of the things you'll notice here is we don't deal with pointers to physics bodies anymore. Physics bodies have been internalized and instead are accessed via API calls. And the reason we did that is because we have a collection of them that's maintained internally. We don't want to have to worry about pointer invalidation and things like that. We should do this in the same manner as we've done everything else in the system and just use handles, right? So we use a handle to essentially represent the body. And then if we need to set or get anything having to do with that, we just do it through a simple function call, right? The overhead of that is not very significant, and generally speaking, you don't have to input and output a whole lot of information about the physics system, at least not from a user perspective all the time, right? The thing that I would say that probably does that the most is probably the scene. So essentially what we have here is we have our create sphere, create rectangle, and create mesh. These look somewhat familiar or somewhat the same as before. We have position, radius, but now all three of these take mass and inertia too. And I don't fully have this figured out, but essentially what these are is mass represents how much something can accelerate and decelerate and various other things. It directly affects how objects move in the world, right? And then we also have something called inertia, which I don't know if I'm going to keep this one or not, but the intent behind this one is to have another sort of dial to say, hey, if we are proceeding in a direction with any direction via velocity with this particular physics body, and that abruptly changes directions, or a force is applied to it or something like that, how much should it sort of keep going in the current direction that it's going in before we actually start applying that, right? It's sort of a fuzzy value, and that's kind of my thought behind that. Mass technically should be doing a lot of that, but I found the need for an additional knob to sort of tweak here. So that's what that is. Again, it's experimental. That may or may not be staying. And so world works exactly like it did before, so I don't really need to cover that. We just have our create destroy, setting the active world to a particular world. That does work through pointers, and the reason for that is because whatever creates the world is also what owns it. And then the physics system itself just maintains a pointer to that. And that is okay because we don't have a bunch of them, right? We just have really one or maybe two in some scenarios. This makes sort of sense to use pointers with. So the only thing you can really do with the world right now, and this will be expanding too, is you can add or remove a body from it, right? Eventually, we'll be able to do things like setting the gravity. Right now, it's only set when we create it, right? But maybe we want to modify that, midstream. But we'll add those things as we need them. And that's kind of the overall theme here is we're going to add stuff as we need it, right? So we have obviously a physics body destroy, and then we have all of the set position, set rotation. And then we have a rotate to apply rotation. That's what we use to actually turn our vehicle, right? And then we have a apply velocity where we can set velocity directly, or we have a set force. And so a force is something that is applied for a single frame or single update to the physics system. And we'll get into that in a little bit. But basically, that's a one-time force that is applied against a particular body, right? And if you want to continuously apply that, then you just continuously apply and set force, right? And that's cleared at the end of every frame, right? So we have that. We have the orientation get. I think we had that in place last time. Maybe not. I'm not 100% sure. And then the velocity get we have as well to be able to get the velocity directly. And then we have something here called apply impulse, which is not implemented yet, right? So we'll be getting to that eventually. So in terms of the actual physics system itself, the most important thing here is system fixed update, which is another thing we actually have to talk about. But before we get into that, I did see that Kuju is actually raiding with a party of 27. So thank you, first off, so much for the raid, Kuju. I appreciate that. How is your game coming? What are you up to? What'd you get up to on your stream? Welcome, raiders. We are, let me give the quick and dirty introduction for those of you who haven't been here before. We are building something called, hang on a second, window issues. We are building something called the Kohi game engine. And we're building it from scratch using C and Vulkan as our initial rendering backend. It's sort of designed to be sort of an educational series on a way to build a game engine. It's not the only way to build a game engine. Not even necessarily always the right way. Sometimes we do it the wrong way just to kind of explore that, right? So it's an experimental series as well. And we've been going now for a few years. It's open source. It's free and open source, rather. So all of the code is available on GitHub. I'll actually drop a link into chat for you guys. And then it is also royalty free, right? So there will never be any sort of licensing fees or royalties of any kind. The only thing is it's Apache 2.0's license, which basically means all that I ask is that if you use it, you say you used it. And so it's cross-platform. It runs on Windows, Linux, and Mac OS at the moment. And then we've got some other links here on the main website, just the YouTube channel, Twitch, Discord, GitHub, Patreon, all that good stuff. And so that is the game engine, but we are actually starting to build our first game with it as well. And we're actually the third episode into that process. And so one of those things that we needed was a physics system. And so true to the series, we are writing one, albeit a simple one, from scratch. And that is what we're working on at the moment. Let's see. Worked on pathfinding and then actually got ARM32 Jai working on my little handheld game device. That is awesome, Kujo. That's freaking sweet. Congratulations on that. I'll have to check out the stream because I haven't gotten a chance to in like a week or two, I want to say. I lurk in there quite often, but I'm not always able to watch all the way through. So I'll have to check it out. But yeah, thank you again for the raid. Let's see. Can this physics engine support vehicle simulation, a simple car with suspension? Not yet. Eventually, yes. We literally just started writing it, though. So the physics engine that we have here in place is literally the only thing I have working correctly is sphere collisions with triangle-based meshes. And so obviously we're going to expand on that. I've got other types of bodies in here, like the rectangle, for example, right? Eventually we're going to have all kinds of other physics bodies. We're going to have, various different solvers that you can add and constraints and things like that. But we got to build it one step at a time. And the other thing is I'm only building what I need. So right now I don't necessarily need like a wheeled vehicle simulation, not yet. But when we get to that point, we'll go ahead and add it, right? Good to see you, by the way, Singy. All right. Gonna grab some dinner. Have a good night. All right, Kujo. Yeah, have a good one. Thanks again for the raid. I appreciate it. Okay. So, we were going to talk about fixed update. So we did actually implement fixed update loops, or the fixed update loop in the game engine. I'm going to put a pin in that and come back to it. Just know that when this gets called, it is a fixed update time. We're no longer using sort of a delta frame time type of thing. We have a actual fixed update loop that calls. At this point, it's set to 60 FPS, right? So this is why that's fixed update time, is because we can rely on that. So we'll come back to that, but the actual update itself, and again, you can see I've got like commented stuff in here. This is very much under construction. But the way that this works essentially is obviously we have to check to see if we have an active world set. If we don't, there's nothing to do. Then we go ahead and we get a step delta, right? So that's how many steps per frame we have configured. Now I have that set to 10, but that is a configurable item I think I put that in the app config. Let me see. Did I put it in here or did I actually just hard code it? I might have hard coded it. I might have hard coded it. Yeah. All right. But it is, there's a state config here, right? So I think I may have hard coded that in the engine. But I need to get that added to app config. Anyway, the structures for it and whatnot are set up for it to be configured. I just don't think I'm actually parsing it out of the file. So we essentially get a time slice from this fixed update time. So we essentially take that, which is 1/60th of a second, and we divvy it up however many steps we have. I happen to know off the top of my head that that's 10. So we essentially divide that by 10, and then we loop that many times, right? And we essentially call this physics step with the step delta in time, right? So the reason we want to do that is because we want to iterate over our physics more often than we have frames, because typically you need to make more than one correction for a complex set of collisions. You may have to actually correct more than one time, and that's kind of a common scenario. And so you don't want things bouncing all over the place or overcorrecting or things like that. So we actually we have 10 steps now. I can bump that up or bump it down as needed, but 10 seems to be a pretty decent number. So that calls this physics step, which processes the whole world. And then after we have done all of that, you'll recall that I made a comment before where we reset the force on each step. So the force that was applied, we just go through any physics bodies that are in place, and we just zero out the force, right? So when you apply a force onto a body, it's only for that particular frame, within all the steps of that frame, of course. And then at the end of that frame, that force is removed. And so that's a very easy way for us to control when force is applied versus it not being applied, right? So in physics step, this is where we sort of loop through all of the various bodies, right? And I've got probably too much stuff going on here. I probably need to split this up and clean it up a little bit, but I'll walk you through essentially the way that it works. So the first thing we do is we take our gravity, our configured gravity, and we get the step amount for that. And that's going to be a common theme. We're going to scale a lot of things by that step time. We loop through all the bodies, and then we essentially have a body that we're solving for, and then we'll have a secondary body that we're solving against. And so the body that we're solving for always needs to be a dynamic body. In other words, a body that responds to and can move from collision events, right? And so we used to have a flag called dynamic or static. And now the only difference between those two is if mass is 0, it's considered static, and that's the default. And then if it's anything other than 0, then it's considered dynamic. So we essentially go through all of our active world's bodies, and we say, hey, if this exists at this particular spot in the pool, which is another thing we have to touch on, then go ahead and check to see if its mass is 0. If not, it gets skipped, and we go on to the next one, right? So we always want to be solving for a dynamic body because we don't need to solve for static bodies, right? So that's a little bit of an optimization there. So the first thing we do is we apply gravity. Pretty straightforward stuff. The next thing we do is we calculate acceleration from the force. So that is basically just taking the force amount that we have and scaling it by the inverse of the mass times step time. and that gives us the acceleration. So if we continuously apply force, that number will go up over time, essentially, right? The next thing we do is we take into account inertia here. And so inertia is, again, just the inverse of 1.0 f plus the body inertia times step time, right? We get the max between that or float epsilon, which is a really, really small number right there. And so we just do the inverse of that, and that gives us our inertia factor. And then we can adjust the force by that inertia factor, right? So that's what helps us, even that out a little bit and make it feel a little bit more natural. Then we go ahead and apply the force, so we just add that to the velocity. And then we update the position. So we basically just take the body position, we take the velocity, and we go ahead and apply step time to it, right? So we scale it by step time and just add that in. And then here's where we do all of the collision checks, right? So we keep a collision count and an overall penetration depth. We'll need those later. And then essentially what we do is we loop through all the bodies again. Now, I do have a note here. Some sort of spatial partitioning here is going to be needed, right? Like an octree or something. But right now we're just, basically looping through all of the bodies in the world. So, the way that this works is now we are trying to get what we're going to call body 1. So body 0 is the first body that we're solving for. Body 1 is what we're solving against, right? So we repeat the process. We get something that actually exists out of the pool, and then we just check it really quickly to make sure that, hey, we're not comparing ourselves or going to process ourselves against ourselves, right? We just make sure that that these two aren't equal, right? That we haven't grabbed the same thing twice. If they are different, then we call collide bodies, right? So the first body that gets passed to collide bodies is always the one we're solving for, and the second one is what we're solving against. We pass in the step time, and then we pass in the address of collision count and penetration depth. And that will give us either one or a total of those things, and we keep track of those, right? This will return true unless there has been some sort of error, okay? So we'll get into the collision and response, but this is basically the collision and response combined into one. And then those are split up within there. All right, so this last bit down here is if we had no collision, then we are going to apply drag through as if we're flying through the air, right? And the reason for this is because when you think about the way that force is applied, right? Force is applied, and then if you're moving along a surface, you're going to have friction on that surface, which is going to slow you down. But if you're in the air, that force just keeps pushing, right? And so what that's ultimately going to mean is that you're going to go really, really fast when you have no drag flying through the air, right? And so we artificially essentially calculate drag. Well, part of it's artificial, part of it isn't. So I did a little bit of looking up on calculating like air density based on elevation, things like that. And I've got some notes in here about that. But essentially we calculate what the drag should be based on the speed that you're going, the overall mass, which is here, and then the actual air density, which we figure out based on elevation. And so we get all of that information. And then we have this hack in here, which is a friction multiplier, right? And so this is sort of the way that we manually can kind of tweak this, right? If we didn't have this in here, we would be able to gain way too much speed, but just by jumping ramps and stuff. So this is going to be something that we're going to want to apply probably to a individual body to say, hey, when this thing is flying through the air, apply additional drag or something like that, right? And that's basically going to, account for, the shape of the thing, essentially, catching air and stuff like that as it flies through the air, right? So we'll be able to tweak that. But for right now, I've just kind of applied one of those based on speed. Anyway, so what we do here is we take the drag acceleration, which is basically going the opposite direction that we're moving, and we're adding that to the velocity, right? And then we update the position again afterwards, right? So that's what kind of slows us down afterwards. And so there's that. That only happens if we haven't had a collision, right? This wouldn't be valid to do if we did have a collision, right? Because the collision would be handling that for us. Okay, so the only thing we haven't covered is collide bodies, and we kind of talked about this in the last stream, and we kind of started laying out some code. And so I'm not going to go into like every single one of these functions, but you can kind of see how this works from here. So the first thing we do is we switch on the shape type of body 0, right? That's going to tell us what kind of collision we need to handle. And so in our case right now, we are a sphere, right? So we're going to go into this case right here. And then inside of that, we switch on body 1's shape type. And the only other thing in the scene that we're colliding with is a shape type of mesh, right? So we have sphere to mesh collision, right? And so that's going to use check sphere triangle collision, right? And it's going to use the triangles within the body itself, right? The target, or the body that we're checking against, right? So we say here is our position and our radius for the sphere. That's us, and then the other thing that we're checking against is the mesh, right? Now you'll notice that this runs in a loop. That is because we have to check all triangles. So again, we have an optimization need here that we're going to have to do eventually. We're going to want like a bounding volume hierarchy here to do this so that we don't have to check all triangles, right? But for right now, we're just brute forcing it to make sure it works. So we check all triangles on the mesh for collision. We keep account of those. We accumulate the collision normals, right? So when we collide, we say, hey, what's the normal of the collision? That's returned to us here. And then we add that to the accumulated collision normal, right? So we keep track of those. We accumulate all of those. And then we also get the max depth penetration, right? And we keep track of that. Now, this works for the most part, but I think we may have to adjust how this works. But essentially what we're doing, rather, is we are taking more or less an average of all of the collisions that have happened. So with a triangle mesh, we may be in a corner or something where we're hitting more than one triangle. And so we need more than one correction. And so we take the average of all of those corrections, and that's what we actually pass to resolve collision down here. So if there is a count, meaning we did have collisions, then we go ahead and normalize the accumulated collision normal so that we just have a direction. And then we go ahead and pass that to resolve along with the max depth. And that seems to be pretty reliable. It's not perfect. And I'll show you kind of some of the ways that isn't ideal. And I've got some other ideas on how we could actually get around that. But that is essentially the pattern that we follow for our collision detection and resolution. The other thing here is, if we're colliding with a sphere, it's kind of the same thing. We have sphere-sphere collision, or OBB sphere collision. And then down here we have obviously a rectangle shape. Is if we're a rectangle shape, then colliding with a sphere, and that calls that same thing. Or if it collides with another rectangle, it's got OBB collision. And then if it's a mesh that it's colliding with, then we check OBB triangle collision, right? And so again, we've got the same optimization notes in there. And so these ones with rectangles, I haven't worked on as much, so those aren't stable yet. So I'm not going to demo those. The other thing is we do not support dynamic shapes or dynamic physics objects that are based off of meshes. It just is a little bit more expensive than I think we should be dealing with, frankly. So right now, if we do that, that just throws an error, right? Okay. So let me go ahead and catch up with chat here, because I know that was a lot. Let's see, I'll start on the Twitch side first. Let's see. Do you worry about the position in the world, or do you only care about the distance between or lack thereof of objects? So, yeah, one of the things that we have to address is having some sort of spatial partitioning system so that we don't have to loop through all the objects all the time and do distance checks on them and stuff like that. We only want to sort of localize things that could actually collide with one another. Let's see. LaFoley, how's it going? Good to see you. You're doing Euler integration. Does Kohi support fixed time steps? So yes, we just haven't gotten to that. I just added that actually off stream too. So we're going to go over that as well. Shouldn't these physics calculations be handled by the game, not something internal to the engine? Like the engine is a piece of generic piece of software. Different games have different physics. Yes. So the idea here is that we're building a very simple but generic physics system that's going to be adjustable to the game's needs. Now, granted, the system that we're building here, we're only building what we need for the first game initially, but you could make other games with it and just expand on it. So all of the stuff that's generic to the to any kind of game should be in here. In this, I do have some stuff that is game specific in here, but those are all marked with hack tags and stuff like that, and we're going to be able to address those from the outside, from the game code eventually. The engine should be responsible for stepping the world, but what physical effects happen during this update isn't that something for the game to define? Yes, but via parameters to the physics engine. Mr. Bobby Bugatti, first time chat. Welcome. I am good. How about you? Thank you for asking. Most engines I've seen work with offer some basic physics for gravity and collisions. Yeah, exactly. So we just want to have something that's very, very basic, right? And we'll build on top of it as we need more stuff. I just don't want to go crazy and like build an entire thing, right? More than likely, if we need anything that's more advanced than what this game is going to require, we'll do like a PhysX plugin or something like that. Is it built completely from scratch, or does it use an API like GLFW? Forgive my ignorance. No worries about that. So it is built from scratch. It uses all the platform layered stuff is all written by hand. The only libraries that we use are to import various asset types. So we have one that like imports MP3s, one that imports images from different formats, one that imports font files, but we convert those to our own internal format, and then the runtime actually uses the internal format. So that's the only place we really use libraries. Everything else is written by us. The drag thing was pretty specific IMO. Yes, it is. And that's why I'm saying like that's going to be another knob that you're going to be able to turn externally. And the settings for that are going to be, exposed but not set, right? And probably disabled by default. And that's an example of something I would configure from the game. But the actual logic of it would be here. How do you solve collisions? Do you overlap them and then push them apart? I used to do that, but there were a lot of problems, so I moved to another thing. I'm only working in 2D with almost no research behind. Curious to what you're doing. That is basically what I'm doing, yeah. So I just move it, and then I say, hey, are we overlapping? If we are, figure out what that overlap normal is, and the penetration depth, and then move out. That's essentially what it does across the board. All right. Let me see. Publish your own game engine. Working on it. Yep. Why C and not C++? A few reasons. So preference, right? Because when I did use C++, it looked remarkably like C anyways. I called it C++ Lite. I don't use OOP or most of the features of C++ anyways, so I figured, well, why not write it in C. Also, C compiles a heck of a lot faster than C++ because it's a simpler language. I don't know. I've grown to prefer it over C++. Right? I could use C++ if I have to, but like most of the stuff for C++, I don't really need. The one thing I really kind of wish that I had would be maybe operator overloads, but for like the math library, but that's about it. Let's see. Rebuilt my NeoVim config only to use the HJKL keys instead of the arrow keys for movement, and my brain is not happy about it. Yeah, I'm going to have to bite the bullet on that one of these days. I do both. But yeah, I use the arrows still quite a lot. C++ is extremely convoluted in terms of syntax. It's a very complicated language. I prefer C personally. Yep, I totally agree. 100%. Okay. I guess we should probably step into really quickly, because we've brought this up a couple of times. Let's see. I did a little bit of moving stuff around in the engine. So the engine loop itself is a heck of a lot shorter than it used to be. But essentially, we now have a fixed update loop, right? So the way that this works, and this isn't perfect yet, but it's a heck of a lot better than it was. So the way that this works is we have an accumulator that accumulates time, and as we run through, thank you for the follow, by the way. As we run through the loop, we essentially say, what is our fixed update time? If we have accumulated more than that, then we go ahead and we do a engine fixed update call, right? Passing through the fixed update time. So our fixed update time right now is just hard-coded up here, right? I have a to-do to make that configurable. But for right now, it's 60 FPS, right? So every frame or every loop here, we accumulate some time via the delta, which is just gotten from current time minus last time. So we take that and then make fixed update calls along that, right? And then decrement that from the accumulator. So no matter what our frame rate is, no matter what is going on there, we always have that fixed update happening with the same amount of delta time, right? So we call that as many times as we need to. And then once we get down here, past that, once we don't have enough accumulated time for another fixed update, then we go ahead and do a render, capture the frame end time and elapsed time. And then we also have a frame rate limiter here, which is available on debug modes. So I actually have the ability to clamp the FPS now if I wanted to test for low FPS. And this is actually exposed in app config. So if I'm testing something and I want to test at a low FPS, I can actually say, hey, I want to clamp the FPS to 15 to test how physics works, for example. I can actually do that, right? And that's what this does. So what this does is it essentially figures out how much time we would need to sleep to slow things down enough to make that happen, and then does a sleep, right? And then it adds that frame elapsed time onto that, and it actually slows down the FPS, right? And then we update our metrics, and then we process our input, right? So most of it is most of what's actually in update and render are pretty much the same. It's just a difference in how much they are actually called now. There are a couple small things though. So all of the stuff, all the systems updates and the application update has all been placed in engine fixed update, and then all the render specific stuff has been put in engine render. So if we go into, well, I guess we can actually start with fixed update first. So this basically just updates the various systems, right? The job system, the plugin system, the audio system. Here is the physics system, fixed update, right? And then it calls the application update afterwards, right? It calls that last. And then, of course, goes ahead and returns, right? So engine render, this is one thing this renderer frame prepare was or used to kind of be mixed into this. I think it happened right here. And it didn't really need to, so I've gone ahead and moved that into render, right? Because it's dealing with the renderer. We shouldn't actually be preparing for a frame in the renderer until we're actually going to do it, right? There's no sense in doing it multiple times, particularly here. So our resize logic has not changed. Preparing the window surface hasn't changed. Actually, none of this stuff has changed, right? This is all the same stuff. I don't think any of this has changed, actually. Just where it sits in the engine file has changed. So it's a little bit better organized now. I can go straight to an update function or straight to a render function and get an idea sequentially everything that happens there. Just because C++ has a lot of features does not mean you must use all of them. Exactly. Bo makes games. First time chatter, by the way, welcome. Yeah, that's been my thing, right? My C++ has always looked more like C than C++. So I figured I might as well just use C, right? The only thing I ever used was operator overloads, constant expression for some stuff, and null pointer instead of 0, but that was about it. First time chatter, long time viewer. Usually sleep when you're alive. Wait, when you're live, yeah. I appreciate that. Yeah. Yeah. Well, welcome anyways. Welcome to the chat. And I appreciate you being here. Okay. So that's our fixed update loop. The other thing I wanted to briefly talk about was something that made an appearance in our physics system. Is this kpool, which is something that we actually haven't seen yet either. So this was something I wrote over the weekend as well. Actually, I wrote most of this over the weekend. But kpools are a new type of allocator. You can think of it as an allocator anyways. It's technically a container, I guess. Container/allocator. It's kind of a little bit of an overlap there. But essentially what it does is it is responsible for creating a pool of memory that you can grab elements of the same size out of, right? So you create a pool, tell it the element size, tell it how many, what's the max capacity of it, and then you can allocate or free, or you can free by index, or you can get a pointer to the pool's memory by index, right? Which is one thing that we're doing a lot. So the advantage here is that we don't have all of that repeated logic that we keep having to do for all of our systems that use handles and resource arrays. And then we have to kind of check through each one to see where one is free versus not free and all that other stuff. This sort of gets around that because we just allocate and free out of the pool as necessary, and we don't have to worry about all that stuff. And so when we allocate, we do return a pointer to the memory that we allocate out of it, right? So a block of memory that's this size. But then also we return a index, right? So for systems that are using a handle to reference their objects, this is ideal, right? Because this will become the handle index and into that array, right? And then when we need to retrieve something out of the pool, we use that index to get that. We can also free by it, or we can free by the element itself. We just do it by address, right? So that's all that is. It's kind of something that's been on the to-do list for a long time, and we finally actually got it done. Let's see. Sometimes use lambdas because I write long functions and it's more comfy to have a small function embedded near where I use it instead of elsewhere. Syntax for them is not that good. I wish it was more like the GCC C-nested functions. Yeah, that was one of the things I didn't like about C++ lambdas. I hate the syntax. It's terrible. From C++, I use operator overloads for templates for containers. Yeah, see, I don't touch templates. Namespaces, I don't touch those either. and the ability to have member functions of classes structures. Yeah, I mean, I don't really do that either. And the couple of times that I do, I just use a function pointer. So it's not really, I don't need it. I still don't need it. All right. So what we wanted to take a look at tonight was actually in our track. Because we have this hack defining some hard-coded stuff now. I want to get rid of this. And you'll notice that actually, did I take all the physics stuff out of here? I think I did. I took up all of the triangle lookup and adjacency information. We didn't need any of that stuff. No, there is some stuff in here still. Okay, so we'll have to clean some of this up. Like all this stuff we're not going to need, but I don't want to get rid of it because I do want to put it in a library somewhere. Constrained to track, like all this stuff, we don't actually need that stuff, but we'll get rid of it at some point. So the way that this works now is when we create the track, we create the points, right? We set up the segment resolution, and then track initialize. We added a couple of things. So you'll notice we had those sort of guardrails on the side that we didn't have before. Those are two more vertices that we add. So we have a left rail and a right rail, and we can define the height of that and the width of that for each one, right? So that's what this is. And I'm thinking actually in configuration, probably what we're going to do is, since the first point and the last point are actually duplicated, we'll probably just make a duplicate of this in code and stick with it, right, for the last. Or I suppose maybe we should actually see about just like wrapping it around, right, and just not even doing this, but as we're generating the geometry, when we hit the end, just circle back to the first point, right? So let me actually fix that while this code is here first. And then go from there. So let's see. Each segment is defined by a start and end trackable. Okay, so the start and the end. Actually, I think, how many other places do we reference I in here? I don't think we do in a whole lot of places. I think I might actually just be able to mod it right there and have it loop around for me. Yeah, I think I can actually. Let's try that. So the start is basically going to be the point that we're at in this loop, and then the end is going to be points I plus 1, right? But if we're -1 here, this is going to be for each segment. So when we hit the last segment, it should probably be point count, I'm thinking. Right, so if point count, if I is less than point count, then we'll be at 9 here, and then we'd want to loop back around to 0, which would mod that. So let me try removing this and doing, oops, I plus 1 modded by track. Do we not have a segment count? I guess, well, actually, I guess it would be point count. I guess it would be point count. And that should loop it back to the first one. And then that's what we use to generate all the vertex data. That might actually be enough to keep us from having to duplicate that last point, because that's been kind of annoying me. Oops. So let's go ahead and try that really quickly. It'd be one thing I'd be able to Okay, so it doesn't look like... Yeah, we've got a hole there. Okay, so how did we... Oh, we've got a segmentation fault. All right. All right, we'll deal with that in a minute. That might just be fallout from this. So we have 10 points. We have 10 configured here. So, you know what, we should probably do this. We should probably do, whoops, U32 segment count equals, well, I guess segment count is point count, isn't it? I guess we could be explicit, right? And just call it that so it's a little bit more clear. So segment is segment sub I. So we have, this would be 1 segment, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why didn't that work? So this should be modded by point count. So that should flip back around to 0 for the end segment. I don't see anything wrong there. Maybe there's somewhere, though. Maybe there's somewhere where we're doing point count. No, this is constrained to track. Point counts. Those are the only places it's actually used. And then constrained to track. Okay. So here's where we're generating all the vertices. We know that's right. Ah, okay. This is only done. I think this is now going to be wrong because we're not doing -1. I think this probably, I have a feeling that if can actually go away. I could be wrong about that. Yeah, for namespaces, just a preference thing. Yeah, I agree. Prefer to write kphysics initialize than kphysics underscore initialize. Yeah, I mean, I get it. I get it. All right, so that was obviously not the right call. All right, so generate index data per segment. This looks forward to the next tessellated face. So skip the last iteration. Okay. I don't feel like that's wrong either. Yeah, the only thing that I see here, it's an off by 1 stupidness issue, I think. Right? I guess I don't need this. So this was point count -1. I can't imagine that that's correct. Because point count minus 1 would only get us to here. Our point count is 10, so it would only get us to index 8 because it's less than, I mean, unless we did less than or equal to, but that seems kind of stupid. Lines of code isn't important, but do you know how many lines of code your project is? Here's the answer. 78,672 lines. Now, some of this is like comments and stuff. Some of it's build files and stuff like that. But as you can see, an overwhelming portion of it is C and C++. Well, okay. So it says C++ header because it can't tell the difference between an H file, whether it's C or C++. So it's just assuming it's either. But yeah, that's the answer to that. Am I just being a dingus here, or am I missing something that's really, really obvious? That should just wrap around and use this same point. How is that literally any different from just duplicating the point and then saying point count minus 1 here? Like, if I do this, it's going to cut it off by another segment. Actually, it doesn't look like it did. Still missing one segment, actually, it looks like. That doesn't make any sense. Yeah, it's the same piece of geometry missing. Oh, I know what the issue is. The issue isn't here. Although, I'm fairly sure that's still correct. The issue is where we are doing the segment count, right? This is probably wrong. So how many segments we have? Wait a minute, why would that be wrong though? Collision track segments. Oh, segment count here, DRA length. That's why we're getting issues right there. There it is. There's the problem. I bet it works now. Actually, it's probably not going to work because I have a -1 somewhere else. Yep. I need to go back to this. Now it should work. There we go. All right. So this feels pretty good in terms of, except for the stupid camera issue that I still have to figure out, but in terms of like the way you take corners and stuff, I think it feels pretty natural actually. Yeah. I'm pretty happy with that. Okay. So let's make this configurable. So we ought to think about first how we want that configuration to look, right? Because this is kind of a verbose thing, right? So we could go with a super verbose type of configuration for it, or we could kind of try to compress it a little bit. But I want to get it in the actual scene config. So if we open up track 00, what we'll do, and this is actually going to be the better way to load it anyway, so we can get the hackery out of our other stuff anyways, out of our main file, right? So we've got all this other stuff in here. I guess it doesn't really matter where I put it, right? But let's go ahead and define it here. We're going to say name. Am I programming behind my head? Almost. You know what? Let me do this actually instead. Let me open the track over there and open the scene configuration file over here. All right, so we're going to set the name just to track, I guess, right? And this is going to be the name of the node. The X form. Actually, I'm just going to take this guy up here. We don't really want to do much of anything with it. We just need to have like an identity transform. So I'm actually just going to shorten this to identity, right? This should be 1 and then 1. Okay. So we have position X, Y, Z, quaternion, so X, Y, Z, W, and then scale, scale, scale. Okay. So the next thing we're going to need is attachments. And this is where it's going to get a little bit weird because we've got to actually figure out how to get game-specific attachments working in our scene, which we don't actually have yet. So that's going to be something that we're going to have to address as well. But we really want the scene to be managing this thing, not our game code. So we're going to do type. And I'm going to say the type is going to be equal to... how do I want to name this? It's like a custom type. I guess racetrack? I don't know. I don't like that name either, but fine. I guess we can say maybe the type is custom track. I don't know. Whatever. Doesn't really matter all that much. So there's not going to be an asset. There's not going to be a package for this. It's not that kind of attachment. It doesn't need to load anything as far as that's concerned. So what it's going to consist of, let's see, is it's going to have just points, I think, and segment resolution. So we can put that first. This doesn't need to be in quotes. So it should be segment resolution. We're going to stick with 10. And then we're going to do points, right? And so points is going to be an array. And so, like I was saying, we could have some sort of super compressed type of format like this, which I think is not all that readable, right? But what I'm thinking is maybe we have a position, and then maybe we do the left side properties and the right side properties, right? So it doesn't necessarily get read in all this way because we just kind of added properties here as we needed them, but we can maybe organize them a little bit better. And so I guess we could do, for each one of these, we'll do position, right? And we'll just take this for now. And we'll slam that in there. We do have to remove the F's and the commas, because those aren't actually needed in here. Right, so then we have the position that's like the center point, I guess you could say. So that's what the whole thing is based off of. We probably ought to do rotation, right? So that's actually rotation Y. So this first one's going to be 0.0. And that's basically the rotation on the Y-axis. And then we have like left width, height, left height, and then left rail information. So I guess we can do left is equal to kind of its own thing, right? And then we can do width equals, let's see, for this first one, it's going to be 10. And then height is going to be equal to 0 in this case, it looks like. And then we'll do rail height, right? That's that sidebar that sort of comes up. You could actually use that and flatten it out and extend the track even further if you wanted to. You could use that for that as well. It's just another row of geometry, right? So the rail, let's see, the rail, do we do rail height and then width? I guess we do. Okay. So let's just expand that over a little bit. So rail height in this case is going to be 7. And then rail width is going to be 3. And that's like what the left side would look like, right? And then the right side would basically just be something very similar, but all the right properties, right? So this this one on the right side is 12 units high, or 12 units wide rather. Or was it? Yeah, and then 0.25 high. And then rail height is going to be, let's see, it's height then width. So 1 and then 3. 1 and then 3. And so that's essentially what each of these points would wind up looking like. And then the idea is also that a track would need to have at least 2 points, I'm thinking. No, at least 3 points to form a loop, right? Actually, now that I'm thinking about it though, technically speaking, we could have tracks that just dead end, right? Maybe they don't all loop. So we should probably have that be configurable as well. So we could just say loop equals true, right? And so by default, if the track loops, then it would connect the last point to the first point. If it does not, it would just leave it disconnected, which means we actually need to update our logic here a little bit, because right, what we have in here is true logic for that, right? So we can get rid of this. We'll do point count 10. And then when we are doing segment count, that's going to either be, if it loops, then we have the segments are going to be the same as the number of track points. Otherwise, it's going to be out track points minus 1. Oh wait, no, I can't do that. That's not where I want to put that. This needs to be point count, and then I need to do it here. U32 segment count equals loops point counts or point count minus 1. What did I? Oh, because it's already defined up here. Okay. All right, that's fine. So I guess we should probably store that on the track somewhere, actually. So let's do that. Indicates if the track loops, i.e. the last point connects to the first. So if that is false, then we should see the gap like what we saw before, right? So we'll start off with true, and actually we'll just do out track loops, right? We'll just define that now. And there we go. When we are doing this, we want to do this same segment count thing, right? So we do, I knew there was a reason I was thinking of separating these out. So, okay, so we'll go by segment count here. And then this will also hinge on that, right? So I guess what we can do we'll put this here, right? We'll put end index here. And then we'll do loops, all of that, otherwise I plus 1, which I don't think this actually matters as much. I think we're going to have, I don't think we'll hit this actually. But I'll put it in there for now anyways. Okay, let me run that really quickly. Let me make sure that this version works, and then I'll turn off the loop and see if that works. So we can see that segment's right there. Let me just go all the way around and make sure that we don't have any weirdness going on there. Okay, track looks complete. All right, so let me take this and flip this to false, which should basically mean that we have a hole right at the end of our track. And then we can just expose that property configuration. Yeah, so we have the hole here. So let me just go around again. So this is segment 2, 3, 4, 5, 6, 7, 8, 9. And this is the last one. Yep. And it does not connect. And so we should just fall into nothingness. Yep. Okay, cool. So that works. And now we can basically just hook that up to configuration. So this is, I guess that should be loops, right? Okay. So this is what I'm thinking our configuration is going to look like for the track, right? So we need to set up like a configuration structure that we can then pass into this and get this data out of it. And then I'll have to copy all these points, refactor them into all of this, and then go from there. So I guess what I'll do is let's create the configuration structure first to make sure that I can actually stand up all of this with everything I need from that. So wherever we've created the track, we're going to go ahead and create a track configuration. I just realized I spelled physics world here wrong. That's pretty funny. Let's fix that. All right. So we're going to do type def struct track config. Let's see. Big launch ramps. Yeah, exactly. We're going to have lots of ramps and things to jump off of. We're also going to have, once I get the oriented bounding box stuff working, we're going to have like different obstacles and things you can run into and jump off of and ramp off of and things like that. And we might even do like breaks in the track with like a ramp on one side that you jump over and land on the other one, and if you fall in between you die or something like that. All kinds of cool stuff. C# or Java for backend? Neither. This is all C. Let's see. Do you plan GUI? Yes, we have plans for GUI. We already have the start of a system in place as well. Hey, I really like that you're developing this engine throughout a whole YouTube series. I've started it a few times, but I wanted to try it out in Zig. But my day job burns my motivation recently. I totally get that. But yeah, good luck to you in doing it in Zig. Let me know how that comes out. Yeah. Let me know how that works out. I'd be interested to hear it. Awesome. Cool. Flask, how's it going? Good to see you. Does the type def buy you something more than just saving you from having to type struct when you declare a variable? Haven't done much C. Yeah, that's pretty much the reason I do it. It's just so I don't have to type struct everywhere. Yeah, that's pretty much it. Okay, so our track config, we need a couple of high-level properties. Do we need to bother with a name? I don't think we need to bother with a name. I'm not going to bother with a name. We're going to do a U32 segment resolution. We'll do a B8 loops, right? And then we'll do an array of points, right? So we'll do U32 point count. And then we'll have to type def what those points look like. So we're going to do track point config. All right. And so each of those are going to have a vec3 position, a F32 rotation Y, and then a left and a right configuration, right? So we're going to call this, I guess, track side configuration. So type def struct track side config. Track side config. All right. And that is going to have F32 width, F23. Dyslexia, dingus-oriented programming. All right, F32 heights, F32 rail heights, and F32 rail width. Let's just make sure that we have width, height. All right, and then we have here we're gonna have track side config left and track side config right. So that'll cover all of that, and then here we'll have a track point config array called points. Now, I think we can just pass in track config, which means here we can do that and then start actually pulling all this stuff out. So essentially what we're going to have to do is we're going to have to like loop through all of our points, right? And do some validation, I guess, some things like that. But essentially extract all of this data and create these track points, right? The other thing is these, let's see, the out track points does not need to be a D array anymore. So we should probably get rid of that, right? Although, well, maybe not though. Let me keep it as a D array and let me explain why. We eventually are probably going to want an editor for this, where we can not only move around the points with Bezier curve handles and stuff like that, even though they technically exist, we just can't edit them right now. But we're probably also going to want the ability to add and remove points. And so if we do a D array, that will make that very easy because we could just add or remove them out of the D array and then rebuild the geometry based off of that. Yeah, let's keep that as a D array. I was tempted to not do that, but yeah, I think it makes more sense to do that. So we're going to do out track loops equals config loops. And then let's see. We have segment resolution was another one. Segment resolution pulls from there now. And we should probably also say, if not outtrack or if not config, turn false, right? Because that is rubbish. We can't just have one without config. Even if that config only contains like basic properties and we add the points later or something stupid, right? Let's see. Looks like what debugger do I use? I use the editor that shall not be named, which somebody already said it in there. I always, try to keep this a family-friendly stream, so I, whenever I have to say it, I say VS, just so that, we don't have any non-family friendly stuff going on here. Let's see. How do you know how you will implement meshes with animations in Kohi? We create a custom format, yes, to export from Blender or use a known format. So we are we are going to use, we're going to have our own format that the engine understands, right? But we'll import from other formats. We'll have some sort of importer that imports to our runtime format, and we'll go from there. Because I don't want our engine having to worry about all these different formats, right? Our importer can worry about that, but like our runtime code that we ship shouldn't have to worry about that. So that's the goal there. You like the debugger? Yeah, I mean, the reason I still use this as a debugger, I don't code in this, but the reason I use it as a debugger is because it's still the most consistent cross-platform experience, right? I could use this on Windows, I can use it on Linux, which is what I'm on now, or I can use it on Mac OS, and the experience is the same, with the exception of, watch variables like this, but that's not a huge deal. I know how to do it in both. But yeah, it's I haven't really found one that's kind of dethroned it yet. A lot of people use that or mvim.dap. I tried mvim.dap, but I had problems with it freezing and or locking up my entire interface, or just not giving me the most up-to-date data all the time, which was kind of annoying. First time chatter, by the way, welcome. Yeah, so it didn't quite work for me the way that I would have wanted. Now, granted, it's probably been a year or two since I've tried that, so maybe it's gotten better. But yeah. What are these things behind you? I have all kinds of stuff on my shelf, if that's what you're wondering. Oh, my on-air sign isn't on. Fail. The wife got me an on-air sign back there, and I didn't turn it on. What a dingus. I'm going to need to move that, though, because my big fat head's in front of it. On-air, boys, exactly. Yep. Yeah. It's... let's see. Yeah. Right there. It's pretty sweet. I like it. You went back to the regular VS debugger because of the memory dump. Yeah, that's fair enough, but that doesn't work so well on Mac or Linux. Yeah. All right. So I guess we probably ought to... I really hate to do this on stream because this is just drudge work, right? I'm probably going to finish filling out these points off stream, frankly. So what I'll do is I'll keep building this now. We'll see if we can get the scene integration working with this, and then we'll see if we can get this going after that, if we have a little bit more time. So point count 10. We're not going to do that. It's going to be config point count here and here, right? We can get rid of the hack because that's no longer a hack. We can do, we can do config point counts. All right. All right, I don't think I'm gonna have to change anything in here, which is pretty sweet, because the only thing was that loops. We've already got that figured out. So all we need to do is essentially just loop through our points array and set them up. So boomer loop incoming. I is less than config point count plus I. So what I'm going to do is I'm actually going to say track point equals, and we're going to do out track points sub I, and we're going to want the address of that. What did I... Oh, forgot a semicolon. Okay, and then we'll also get a shortcut to the config, right? So we'll say track point config. And I guess I'll call that C, right? Just to keep things nice and short. And that's going to be the config points sub I, right? And so basically it's just going to be a property copy, more or less, not 100%, right? Because our configuration is actually structured a little bit more than our end structure. So we'll be able to do p.position equals c.position, p.loops. Wait a minute. Oh, that's not in the points. Never mind. Let's see. We need rotation y. C rotation y. And then here we need the side configs are basically everything else, right? So P, let's do, I guess, the left side first, right? So we'll do, let's see. We need left, what is it? Left width, left height. Left width equals C left width. Left height equals C left height. And then same for the rails, right? So P left rail width equals C left rail width, and then P left rail height. And now I can take all of this, copy pasta, okay. And I believe that is everything that we need to handle. Got rotation Y. Oh, we need to do a deg to rad on rotation Y. So let's put a comment in here. So for our rotation Y and the configuration, we're going to use degrees. But in our internal rotation Y, oops, we're going to use radians, right? Just makes it a little bit easier to configure when you're thinking about, writing this out. So we're going to do deg to rad. There we go. That's the last thing that was done in here. And so that should be all we have to do to actually build out our points. And so this becomes a thing of the past. Obviously, we need to translate all those over here, but we can actually move on now to, I think I've got all the hard-coded stuff out of here now. So now we can move on to, oh, you know what? We also need to make it configurable so that Bezier handles can be configured for each one of these points. I'm going to have to think about that, though, because technically each point can have two handles, going backwards and going forwards, right? We're sort of auto-generating that in code right now, but eventually we're going to need that control. I'm going to add that later. I'm not going to worry about it for now. Okay. So that's that. Now, how do we actually set up our scene to say, hey, we have an attachment here of a type that we don't know about in the engine. We need some way for our scene to say, okay, this isn't a type we recognize. What do we do with this? So let's take a look at, actually, this is going to be This is going to be the scene serializer, where this is going to initially be an issue. So let's see, where was that? The serialize attachment, here's the type, attachment name, that's the name. Okay, so the type, this is the type string. Then we find the attachment type. Okay, so this right here is what we're going to have to do. So essentially what we do is we have these known types, right, which are here. And then these essentially map to whatever this is in that array, right? This array maps to this guy. So we need a way to then say, where is the user space on this, right? The user space should be able to define its own types without obviously having to modify this, right? So there should be like another list of these out there somewhere. Either another list of these or some sort of registry we can check, which is what I'm thinking of, that we're probably going to wind up doing, where we have a registry that says, okay, here's a custom type. Here's the string of that custom type. Whenever you get one of these, here is its serialization function. Here's its deserialization function. And then from there, it can build the types it needs, and so forth. The only thing we're going to have to think about is also maybe making we might have to make the configuration of the scene node expandable as well to take in those extra types, unless we dynamically allocate them. Could hash the type string. Yeah, that would be one way to do it. I don't think it's really going to help us, though, because this core serializer is not going to know about this, right? Oops. Wrong window. This core serializer is not going to know about it. So I have to have a way here to say, okay, if we've looped through all of the attachment types that we know about, what are some of the ones that we don't know about, or the ones that are sort of registered, right? And so whenever we deserialize the attachment, we're going to have to also include some sort of information to go along with that to say, hey, here is something you can use to deserialize. Here's some additional type information that we could use. Which really the deserializer isn't even like a structure or anything. It's just a series of functions. So how do we do that? Because we essentially deserialize the entire scene. I suppose what we could do, actually, I know what we can do. Let's not handle it here. I know how we're going to do this. So what we're going to do, we've done this in other places like app-config. When we run into a type that we don't know what it is, right? We have this attachment here and we say, we don't know what this type is. We don't know how to deal with it. What we're going to do is we're actually going to take the source of that, so the inner string, which would be all this, and we're just going to store it off as a string. And we're going to say, hey, this guy actually has an attachment of an unknown type. We don't know what it is. Here's the string of that. When we fire that off to the scene at that point, our scene system, for lack of a better term, can be aware and can have things registered with it that says, hey, when we go to deserialize this thing and we pull the type out of it, you know, string match at that point. And I think it makes more sense to do it at the scene level, because then we don't have to clog up our serializer with all of these user types. If you have a map between the type hash and the serializer, deserializer, you can ditch the enum entirely. I suppose that's true. I could just, yeah, I see what you're saying. I could turn these into like k-names. This whole thing was written before k-names were really started to be used with scenes, so yeah. Enums are nice to work with in code instead of strings. I hate working with strings in code. You're not wrong, though. We could do that. I'm not going to do it at the moment, though, because I feel like that's just kind of getting away from what we actually need to do. All right, so for our serializer, instead of erroring, saying the attachment, the scene node attachment is unknown, we are going to take the, we're going to actually have one more type. And we're going to do, should we do it after count? Yeah, I think so. We're going to do scene node attachment type custom. Can't type. All right, and then I guess we can also, I mean, there's not really a point to doing this, but no, you know what? I'm not going to do that, actually. I'm not going to map that to custom, because if somebody actually has a custom thing called custom, then that's going to be an issue, right? Let's actually make this user defined, right? So if we wind up here, which is going to wind up being the default case if we don't find a matching type, then what we're going to do is we're going to create a special type of typed attachment that's going to be user defined. Should probably do that first. So I guess we could put that right here at the top. And it's going to be a specialized node attachment config. Node attachment user defined config. And we're essentially going to defer defined. We're going to defer the deserialization. So we'll just do a config source just like that, right? So we can do oh, it doesn't like that I right. Switch to user defined, right? And then what we're going to do is scene node attachment user defined. Break. All right, so we're going to do typed attachment So we'll do type, whoops. User defined. Right, so if no match is found, store of the source as a string and deserialize later. All right, so now we can do typed attachment config source. And then I guess we can do, let's see, how did I do that in app config? I don't remember. Must have been in here. Yeah, parse file content. Let's see, how did I do that? I think I called it source. No, maybe not. Might have been under system configs. Here we go. That's what we did. Okay. So we grab the object that contains it and then do a case and tree to string. Yeah, we did this basically. All right. Okay, so let's take that over here. All right, so the property that we're going to want, actually we don't probably even need the object, do we? It's probably just going to be the whole thing. We are probably going to just use attachment object for this, so we don't actually even have to do this. We're just going to do get object. I feel like I missed a step here. So temp. Okay. I guess we do have to do that. We get that as the temp root. Oh, okay. I could do, yeah, I don't have to do this. Okay. I can do just temp root equals attachment object. Is this a pointer? I think it is. Okay. And then typed attachment config source is equal to that. Okay. All right, so just a brief explanation as to what we're actually doing here, because I know that was kind of confusing with me going back and forth. So, move this over. So the way that this works is if we don't find the type, we say, okay, well, we're on attachment type unknown. We flip that to a user-defined type now. And then down here, we say if the type is user-defined, we create a new user-defined config, right, a typed attachment. And then we set up a case and tree. Now, a case and tree, so that you're aware, just contains a root case and object, right? And so what we do is we set the root to the attachment object that we're already looking at, right? So we just dereference that. And then we call case and tree to string, right? So all we have to do is just pass the tree we just made, and then we're done, right? And since this is all done on the stack, anything that needs to be thrown away is thrown away. So we basically just do that, and that defers it to be processed later. So then when we're in the scene, we take a look and we say, hey, is this user defined? Okay, now let's deserialize this, get the type out of it. What do we need to do to actually handle this type? Enums are nice but very rigid. Yeah, that's what I like about them though, is the rigidity. Let's see. Do you think the recruiting industry super messed up by speaking at prestigious conference looks a way to break this, I feel? I'm not sure what you're asking, if you wouldn't mind rewording that. Okay. I think that's all we have to do on the serializer. No, it's not all we have to do. We also need to, so this is the deserialization, right? When we go to write this back out, we're going to have to write this, we're going to have to basically reverse this process, right? So we are going to have to basically say, okay, when we go to write the scene out, we need to be dealing with a user-defined config, right, that has the whole thing already stored as string, and then we just blast that whole thing out like this. So we are going to have to handle that. Let's see. Do we have a serialize? We have a serialized node. So we have a scene node config. So when we do this, oh, we're not pushing it into an array. That would have been bad. I was going to say, where's our type to deal with this? Don't have one. So we need an array added here. Right, so this is going to be user-defined configs. Right? Now we can push this into user-defined configs type attachment. And then we need to essentially undo that in the other direction. So serialize node. And we'll probably just go ahead and handle it at the top, right? I guess that makes the most sense. So if node user-defined configs, we'll just do this essentially. This whole thing. I'm not going to worry about the name. I suppose I could write out the name. Base properties. Cube map name. Okay, I'm going to take this up to here. And we're going to basically just change this to what we need. So this is going to be user-defined configs. User-defined configs. Scene node attachment config. That's user-defined config. Okay. So we are not going to add the type in this case. That is going to be added as part of the rest of it. And in fact, we are not even going to do the name. now that I think about it. We are just going to add the whole thing. We are just going to add the whole thing as a string. I don't remember if we actually have something to just say set the value to this string, but don't treat it as a string, treat it as an object. I don't think we have that. I think we're going to actually have to parse it first and then write it out and then throw it away. Which I'm not a huge fan of, but I guess it's probably the safest way to do it so that we don't wind up with the foobar source code in there. Okay. So we need to case and tree from string is what we're going to want. So the source we're going to want is going to be the typed attachment config source. And then I think it wants a tree. We'll just call this temp. And then all we'll want to do, technically the whole attachment is going to wind up being added. So we're going to want to add to attachment object array. We're going to want to add the root of this. So case in array value add object. And the array is going to be the address of attachment object array. And the value we're going to want is going to be temp root. And then we need to do case and tree destroy. Wait, clean up. Temp. If I could stop typing the wrong thing, that would be awesome. Okay. All right. And that is the only thing we need to do. So we actually don't need this. Yeah, okay. So this is going to be user-defined configs are output directly as is, not processed here. So attachment, do we need? I don't think we need that. Attachment object, we don't need that either. Okay. So we will, I guess this would be serializing. Wait, no, deserialize, I was right. Deserialize. Config source to a tree to a temp case and tree. Add that tree's root as the attachment object. Clean up the temp tree. Okay. I think that makes sense. And again, that keeps all of the custom stuff out of the serializer. It only has to worry about, it doesn't have to worry about like what the format of this thing actually is. Okay. User defined configs. I feel like we didn't create that D array. Right? Like, we didn't. Right, we need to do this. User defined configs, user defined configs, and then user defined config. Okay. Push to the appropriate array. Okay, that makes more sense. Is there anything else in here that we need to do? I don't think there is. All right, so the scene is going to have to come up with some way to handle this. And so that's what we're going to have to think about. It's looking like we're going to have to think about that on the next stream because we're basically out of time for tonight. Yeah, because I have to get up in the morning. I don't think I'm going to be able to handle like the registry and all that stuff by then. So I guess let me leave myself some notes. What I'll do, I'll leave the notes in the scene because that's where we're going to have to work. Initialize. So let's see. Let's do this. And I'm basically just going to scaffold this really quickly. All right, so this is going to be user defined attachments types. User defined configs, user defined configs, user defined config. Okay. And then we're going to do left off. Implements a registry to handle user defined attachment types, which will process the string held by these configs. We'll need a type agnostic way to handle these specifically. All right, we'll go ahead and make session. And then what I'm also going to do is, since we actually have quite a few updates here, right? Not a small amount of stuff. Why is there a settings file update? I hate how it's always updating this, just because I opened a file in there. Easiest place to do it is I'm just going to roll this back. Don't need that one. The rest of it should be fine. Let's see. So, physics, system updates, track config, camera tweening, work in progress. Guess that about covers it. All right, cool. All right. Let me find somebody to raid. should we raid Els Dragoon again? I think we're gonna raid them again because they popped to the top of my list. So that's who we're raiding. And all right, so yeah, thank you guys so much for being here tonight. I appreciate you guys, and I will see you guys in the next one. See ya.